Hello everybody. In this video, we are going to be dealing with compound angle identities. Now, I'm going to strictly say that this video is purely going to be on seeing the compound angle identities, and we are not going to be covering any proofs in this video because I'm going to leave that for a separate video where you have to first prove one of them and then you have to use the compound angle identity to prove other compound angle identities. So that would be in a different video. For now, we're going to learn what the compound angles are, and then we are going to apply them into questions. So there are two types of compound angle identities, right? There's one with sine and then there's one with cosine. I know there's four, but the reason why I say two is because we don't need to memorize all four of them separately. There's actually a way where we can kind of memorize only two of them. However, the only change between each one of them will be the signs. Okay, so we can first look at sine. Okay, so sine, this is what we have. Compound angles is when we have an addition or subtraction of two angles. Okay, so a plus or minus b. Whenever you see sine, the pattern you will always follow is sine of A multiplied by cos of B plus or minus cos of A times sine of B. So this is the sine cos sine. Notice that when you have sine, you always start with sine, okay? But the best way to memorize this in a way so that you don't forget it in the examination is sine cos sine, and you can see here clearly that each trig ratio needs to have their turn with the angles that are on the left hand side. Okay, and notice that if I choose positive on the left hand side, then I'll be choosing positive on the right hand side as well. And if I choose negative on the left hand side, then I choose negative on the right hand side as well. This is how you remember it, just as 1. However, it'll just be the plus minus sign that is over there. So I guess the first one is pretty decent. However, when we get to cosine, so cos of A plus or minus B, this is going to be the order. Notice how cosine is being used. So it'll be cos, sine in this one. So it's cos of A times cos of B minus plus sine of A times sine of B. Okay, that looks like beta. Okay, now let's speak about this one. Number 2, it's cosine, A plus or minus B. Okay, we have a plus or a minus of two angles, and notice how cos starts first. And the reason why I want to do this is I want to do it in the form of AB. Okay, AB is the best way to remember this stuff. And notice it's cos, sine. So sine, it's going to be sine, cos, sine. And cos, it's going to be cos, sine. Okay. And then the only difficult part to kind of remember is the sign change. So like, does the positive come with the negative? Or does the positive come with the positive? This is where the change comes through. You could say minus plus and then plus minus here. It doesn't really matter. But with this one, it's plus. If you choose positive for the left hand side, you use negative on the right hand side. If you choose negative on the left hand side, you choose positive on the right hand side. Okay, so that is essentially how we use these formula. Now let's get into some examples. We'll maybe do like 2 examples using this, and then we can call it a day for this video. So here's our first question. Example 1 says, prove that sine of 90 degrees minus theta is equal to cosine theta. Now, if you look through reduction angles, you would know that that is true. Why? Because you can see 90 degrees minus theta is quadrant 1, and everything is positive in quadrant 1. So therefore, it will have a positive sign, and then because it's 90 degrees, it's a co-function, so meaning you change it from sine to cos. So that is true. However, we want to use a proof. We want to prove that that is actually true. Now, you would probably go ahead and draw the Cartesian plane, but that is not what we're going to do. We're going to do a better method. We're going to use compound angles. Why are we going to use compound angles? Well, you would use compound angles if you have may be the sum or the difference of two angles. Notice how the sine of 90 degrees minus theta is in the form of sine of A minus B. Okay, where A is 90 degrees and B is theta, and we have a minus. So therefore we will use the compound angle that says that sine of A minus B is equal to sine A cos B minus cos A sine B. Okay, remember the sine, cos, sine, and then if we choose a negative for sine, we get a negative for the other side. Okay, so therefore this sine of 90 degrees minus theta is just going to be equal to sine of 90 degrees multiplied by cosine, okay, of theta minus cosine of 90 degrees multiplied by sine of theta. Okay. And then if we simplify this, we'll note that sine of 90 degrees is equal to 1. Cosine of theta is just cos theta. Cosine of 90 degrees is going to be 0. Multiplied by sine theta. And then we can clearly see that 0 multiplied by sine theta is just going to give us 0. And 1 times cosine theta is just cosine theta. Therefore, sine of 90 degrees minus theta is then equal to cos theta, using the compound angles. The next question is example 2 that says, without a calculator, we need to find sine of 75 degrees. So in the last question, we were actually given the two angles, right? However, with this one, we don't really have a special triangle that tells us what is sine of 75 degrees explicitly. I'm talking about 75 degrees. However, what we can do is we can break it up into two angles that may use a special triangle. Now, what two values can add or subtract to give 75 degrees that we are able to use without a calculator? If you said that 75 degrees can be equal to 30 degrees plus 45 degrees. Why? Because we have a special triangle for 30 degrees and a special triangle for 45 degrees. You are 100% correct. So this means that this is just going to be equal to sine of 30 degrees plus 45 degrees. Okay? Doesn't matter what order you have it in, because it's a positive in this case. Just as long as it gives you that 75 degrees, you should be fine. Okay. Now, notice that we have it in the form of two angles where we can say that A is equal to 30 and then it says plus B, which is 45 degrees. And notice it's sine, meaning with sine, what are we going to do? We are going to use sine cos, sine. So it's going to be sine of A, which is 30 degrees, times cos of B, which is 45 degrees, plus, because of the positive sign, we have cos of 30 degrees multiplied by sine of 45 degrees. Okay. And we know using special triangles that sine of 30 degrees is going to be opposite over hypotenuse. I think it's best if I just get the triangles quickly. Okay. So here I just wanted to draw the special triangle so that you guys can also see like what to do, because otherwise I'm just going to be spewing numbers out of my head. So for this one, sine of 30 degrees, we know that 30 degrees is right here, and sine is opposite over hypotenuse, meaning it's going to be 1 divided by 2. Okay. So here we're going to have 1 over 2 multiplied by cos of 45 degrees. 45 degrees is right here, and we can know that it's adjacent over hypotenuse, so it's 1 divided by root 2. Okay. So it's 1 over root 2. Plus, we have cos of 30 degrees. 30 degrees is here again, and it's going to be root 3 over 2 because it's adjacent over our hypotenuse, right? And then it's going to be like that, multiplied by sine of 45 degrees. 45 degrees here, opposite over hypotenuse. Therefore, it is just going to be 1 over root 2. Okay? Great. Okay. Now from here, we can just multiply the fractions. If we multiply this fraction on this side, it's going to be 1 over 2 root 2 plus the other one is going to be root 3 over 2 root 2. And notice that the denominators are the same, so we can just add this together. So it'll be root 3 plus 1 divided by 2 root 2. Okay, and there we go. We've gotten our final answer for this question. Okay, so here's the third one. Example number 3 says, simplify sine of 169 degrees times sine of 41 degrees plus sine of 79 degrees times sine of 131 degrees. Now I know this looks very hectic, and this is the type of question where you need to use the other way around, where you will say the sine, but you're going to need to have to like simplify and try and use maybe co-ratios to put cosine somewhere here in order to use the compound angles. So let's just do it one by one and see how far we can get. Because whenever you get these types of questions, don't stress. Just do it one by one, see what happens, see how you can change it. Don't try and brainstorm the whole thing in one sitting or one thinking session, because you are not the thinker, man. Okay, so now we are going to do this one, right? Notice that this is above 90 degrees as well as this. These are both not acute. These are obtuse angles, meaning let's try and reduce them so that they're also acute with them. Okay, so for this one over here, we notice that sine of 169, notice that 169 can be reduced to 180 degrees. What do we do with 180 degrees to get 169? Well, we minus 11, right? Remember that we need a reducing angle so that we can just find an excuse to get rid of it and then reduce it to this angle, okay? Multiply it by sine of 41 degrees, and then we add it with sine of 79 degrees, okay? Multiplied by sine of, what else do we have? 131, notice that that's also above 90 degrees, but let's use 180 degrees, okay? And we subtract it by something to get this, okay? What are we going to get? It will be 49. Okay, cool. Now we can reduce the angles, and we can say here, because this is 180 degrees minus 11, that's quadrant 2, meaning sine is positive, so it'll just be sine 11, okay? Times sine of 41 plus sine of 79 multiplied by, and this is where we can reduce it as well. We can see it's also in the third quadrant, so it'll be positive sine of 49 degrees. Okay. And then now that we look at it this way, right, we can see that we want to get it in the form of AB, BA, okay? So how can we do that? Now look closely at the pattern here. Look at what we have. We have 79 and 49, okay? What about these two? What is the relationship that these two have with these? Well, notice that if you add 11 with 79, you get 90. And if you add 41 with 49, well, you also get 90. So what we need to do is use another reduction formula. But this time, we need to find a way for these two to both add up and correlate with this. Okay. And remember, the only patterns that we have for compound angles is sine cos cos sine and cos cos sine sine. So if we can use the co-ratios on both the first sines, we can actually change these into cos and cos. So then maybe we can make some progress. So how do we do that? What do we do with 90 degrees to get 11? Okay, but we have to change this though, because we're working backwards, by the way. So it'll be cos of 90 degrees, and then what are we going to do to get 11? We're going to minus 79, right? Notice that I changed cos already, because remember, if you were to work from here back to sine, that would be the immediate step. So we're just doing it backwards. I know it's a new thing. Multiplied by, here we also want to change this to cos. So let's say cos of, what else are we going to have? Well, we are going to have 90 degrees minus 49 in order to get 41. Okay? And notice that they're all in the first quadrant, so they're all positive, so it's not a big deal. plus sine of 79 degrees multiplied by sine of 49 degrees. Okay. Also, by the way, I was talking rubbish. I hope you guys were able to figure that out. Okay. So with this cos stuff, you guys are probably like contemplating it, and I can understand why, and that's good. You must not change it yet. Why? Because under no circumstances can you do the co-ratio method or any reduction yet until you removed your 90 degrees. Okay, so do not make this mistake. The only reason why I'm doing this is because I did this in high school. Okay, I don't know if I'm with anyone over here. Please tell me if I'm not alone here. I don't like being alone. So it's still going to be sine. Why? Because 90 degrees minus 79 is the same as 11. So it doesn't change. And this will also still stay as sine. But now, as soon as we take the co-ratio, or as soon as we reduce, then we change it. Okay? So notice how it's in quadrant 1. So it's going to stay positive. This will be cos of the reduced angle, which obviously reduces to 79 degrees. This one will be cos of 49 degrees. This will be plus sine of 79 degrees. This will be sine of 49 degrees, okay? Do you see that we have cos A, cos B, plus sine A, sine B? And because there's a plus sign, and we know that cos, sine is a form of cosine. And whenever we have a positive on one side, we'll have a negative on the other side. Meaning, this should be in the form of cos of A minus B, where A is represented by 79 degrees, and then B is 49 degrees. As you can see here, look here at this pattern. This is A, this is B, this is A, this is B. Okay, and then let's just simplify this. Notice that 79 degrees minus 49 degrees is just 30 degrees. Okay, and then using our special triangle, we should get an answer of square root of 3 over 2. Okay, so there we go. This one is more of the tricky one, right? But like I say, all you need to do is just go with the flow. Try and achieve like flow state if you can with these types of questions. Otherwise, if you feel like you're getting nowhere, just move on to another question and then come back to this later. Okay, usually these ones are the more tricky ones. Otherwise, the other ones should be fine.